right? So let us first of all assume, let the present age of the Kishore be X years, right? So what will be the Kishore? Vivek's age. Therefore, present age of the Vivek is equal to X plus 5. Because why? What is the condition given over here? Vivek is older than Kishore by 5 years. Means Vivek is elder to Kishore by 5 years, right? So you will write present age of the Vivek is equal to X plus 5 years. Okay, now read the next line very carefully. The sum of the reciprocals of their ages is 1 upon 6. So first of all, let us write what is the reciprocal of the age of the Kishore. Yes, 1 upon X. Reciprocal of Kishore's present age is 1 upon X. Similarly, reciprocal of Vivek's present age also 1 upon X plus 5. Okay. Now, condition given over here is the sum of the reciprocals. Sum of their reciprocals of their ages is 1 upon 6. So, according to this condition, you should write the equation as 1 upon X. 1 upon X. 1 upon X is the reciprocal of whose age? Kishore's age. Plus 1 upon X plus 5. 1 upon X plus 5 is whose age? Reciprocal of whose age? Vivek's present age. Right? So, this sum, reciprocal of the sum of reciprocals of their ages is nothing but a 1 upon 6. So, you will write this equation in this form. This condition you will write in this form. Okay, 1 upon X plus 1 upon X plus 5 is equal to 1 upon 6. Let us further simplify this in the next slide. Okay, what we have done, see, if you see here, the denominator, this is the numerator, right? Denominator is different here, X and X plus 5. Okay, so we can't add. When denominator is equal, then only we can add. So let us first of all equalize this denominator by cross multiplication, right? So what we have done, see, look here. Here we will multiply by X plus 5. And here we will multiply with X. Okay. So what will be the denominator? X into X plus 5. Okay. So let us write that. When we cross multiply, we will get this step X plus 5 plus X upon X into X plus 5 is equal to 1 upon 6. See what we have done here. We have multiplied here with X plus 5. Here multiplied here with X. Means what we are getting? We are getting denominator as X into X plus 5. Yes. This side we are getting X plus 5 plus, when you multiply X with this one, what will getting X. Okay. So this is how, and this side will remain same. It is equal to 1 upon 6. So how will you get in the next step? 2x plus 5 divided by X into X plus 5 is equal to 1 upon 6. Right, students? Okay. So this is how you will get this step. X plus 5 plus X upon X into X plus 5 is equal to 1 upon 6. Further simplification, you will get 2x into X plus X, 2x. Okay, plus 5 divided by X into X plus 5 is equal to 1 upon 6. Now, when you cross multiply, what will you get? 6 into 2x plus 5 is equal to X into X plus 5. Let us further simplify. 6 into 2x plus 5 becoming 6 into 12. 6 into 2, 12. That is 12x plus 6 5s are 30. So you will get 12x plus 30. And when you simplify this, you will get x into x, x square, right? And x into 5 plus 5x, right? So now what will be the next step? Just see this, you x square plus 5x. Now you are bringing this 12x to the other side. Why? Because we want positive sign of the x square. So we have kept this as it is, x square plus 5x, and we have shifted this 12x to the other side. So it will become minus 12x. Similarly, we have shifted this 30 also to the other side. It will become minus. So this is how you will get this equation. X square plus 5x minus 12x minus 30 is equal to 0, right? Now, when you further simplify, you will get this. See, look here, what we are getting. X square, see, when you subtract this, you can see clearly here, opposite sign, right? Plus, minus. So, you have to subtract here. Okay, 12 minus 5 becoming 7. Okay, what is bigger digit sign? Minus, right? So, what will come? Minus 7x minus 30 is equal to 0, right? Now, let us see in the next slide. Okay, so what you are getting here, this step, x square minus 7x minus 30 is equal to 0. Okay, now see, what is the middle term? Minus 7, yes. What is the last term? Minus 30, right? Now, how will you solve this quadratic equation? By two methods. We are not going to use completing square method because this particular method has been omitted for this particular year, right? So we are going to use only two methods. Which two methods? Formula method or factorization method. Okay. Okay, let us use which method here? Factorization method. So let us first of all take last term. What is the last term here? Minus 30. Okay. Now when you take minus 30, you have to find out the factors of this last term in such a way that when you add these factors, you should get middle term. Yes. And when you multiply these factors, you should get last term. Okay. So in this way, I have found out the factors of minus 30 as minus 10 and 3. So when you add minus 10 plus 3, what you are getting? Minus 7. Yes, minus 7 I am getting, and that is nothing but the middle term. Okay, that I want. And when I multiply this factors, minus 10 into 3, what I am getting? Minus 30. That is a last term. Means both the conditions I am fulfilling with these two factors, right? Yes, I am getting middle term also and I am getting last term also. So I can use these factors, right? So let us use these factors. Yes, I'm using now these factors, minus 10 and 3. Okay, now I will rearrange by using these factors. Now I will rearrange this quadratic equation by using these factors. Let us rearrange. Yes. X square minus, which factors I'm using? Minus 10 and plus 3, right? So I'm writing this x square minus 10x plus 3x minus 30 is equal to 0, right? Now what will be my next step? I will find out the common. Yes, what is common here? X is common here. Okay, x into x minus 10. Now what is common over here? 3 is common. 3 tens are 30, right? So I'm taking out 3 as a common. So what I'm getting here? X minus 10. When I'm taking out 3 as a common, I'm getting, when I'm taking out 3 as a common, what I'm getting? 3 into x minus 10. Now again you can clearly see here x minus 10 and x minus 10 is a common here. Again you are taking out this as a common, x minus 10, right? So what is remaining behind? Yes, what is remaining behind? X and plus 3. So x minus 10 into x plus 3 is equal to 0. So now you know the property. Which property? If product of two numbers is 0. If product of two numbers is a 0, then at least one of them is 0. Yes, you know this property. If product of two numbers is 0, then at least one of them is 0. So you can take either x minus 10 is equal to 0 or x plus 3 is equal to 0, right? So what will be our next step? Yes, when you shift this minus 10 to the other side, what will you get? X is equal to 10, right? And when you shift this plus 3 to the other side, what you are going to get? X is equal to minus, right? But what we are supposed to find out? H. H cannot be negative. So it is unacceptable value. This negative value is unacceptable, right? So which value we are going to take? We are going to take X is equal to 10 because we are finding out H, and H cannot be negative, right? So we are assuming, or we are taking H as a X is equal to 10, right? Now once you find X is equal to 10, find out what is X plus 5. X plus 5 is equal to 10 plus 5 is equal to 15. Means in this way you will get present ages of Kishore and Vivek. Okay, so Kishore age is what? X is equal to 10, that is a 10 years. And what is a Vivek age? X plus 5, that is 15 years. So last line is a must. Present ages of Kishore and Vivek are 10 years and 15 years respectively. This last line carries our marks. So this last line is a must. I think student, you must have understood this. Let us go to the next slide. Okay. Suesh scored 10 marks more in the second test than that in the first. 5 times the score of the second test is the same as the square of the score in the first test. Find his score in the first test. Students, this sum also very simple sum. Yes, only you have to read very carefully. This sum also carries 3 marks in the board exam. Okay, let us read again this sum. Suesh scored 10 marks more in the second test. So if you want to know the marks in the second test, first of all, you should know the marks score in the first test, right? So first of all, let us assume what is the score in the first test, right? Then only you will come to know what will be your score, what will be the Swiss score in the second test. And then if you read the second line, you will get what is the exact condition of this sum. Okay, accordingly you can find out, or you can write the quadratic equation. And when you use this quadratic equation by any method for solution, formula method or completing square method or factorization method, you can find out the solution of this quadratic equation, and that is nothing but the what is the score in the first test and the second test. Okay, let us first of all concentrate on the first line. Suesh scored 10 marks more in the second test than that in the first. Okay, so let us first of all assume, let the score of the Suesh in the first test be X. First of all, we need to know the score in the first test. Then only we can able to write score in the second test, right? So let the score of the Suesh in the first test be X. Okay, so what will be Suesh score in the second test? X plus 10. Why? Suesh scored 10 marks more in the second test than in the first test. If the score in the first is X, obviously the score in the second will be X plus 10. Right? Now let us concentrate on the next slide. 5 times the score of the second test. What is the score of the second test? X plus 10. What is the 5 times of the score of the second test? 5 into X plus 10. Right? Now read this line very carefully. 5 times the score of the second test is same. Is same means equal to. Same as the score. Same as the square of the score in the first test. What is the score in the first test? X. What is its square? X square. And what is the condition given over here? 5 times score in the second test is equal to or same as that of the square of the score in the first test. Yes, so this is how you will get this equation. Yes, you will get this equation. What is the condition given over here? 5 times the score of the second test. 5 times the score of the second test is same. Same means equal. Equal as square. Square of score in the first test. I think you must have understood this equation, how this equation is found. Okay. Now, what is our next step? You have to simplify. Okay, let us simplify this. 5 into x plus 10 is equal to x square. So let us multiply this 5 with the x plus 10. When you multiply, what you are getting? 5 into x, 5x plus 5 into 10, 50 is equal to x square. Okay, now let us simplify in further slides. What you are getting? 5x 5x plus 50 is equal to x square. Okay, now what we want standard form of the quadratic equation. So you have to arrange in which form? Ax square plus bx plus c is equal to 0. So let us rearrange in that way. Okay, so you want for x square plus sign, right? So let us keep x square to that side only. Only you are going to shift this 5x and 50 to the other side. When you are shifting this 5x and 50 to the other side, what you are getting? X square minus 5x minus 50 is equal to 0, right? Now, what will be your next step? You have to solve this quadratic equation by any method, by formula method or by completing square method or by factorization, right? Now, first of all, concentrate on what middle term. What is the middle term? Minus 5. What is the last term? Minus 50. So let us take last term, that is minus 50, and find out the factors of minus 50 in a such a way that when you find out these factors, the sum of these factors should be middle term. Okay, and when you multiply these factors, okay, product should be last term. So which factors I have taken? I have taken minus 10 and plus 5. So when I'm adding this, factors minus 10 plus 5, what I'm getting? I'm getting minus 5. Okay, I'm getting minus 5, and that is nothing but middle term. Yes, when I'm adding these factors together, what I'm getting? Middle term. Okay, and when I'm multiplying these factors, what I'm getting? I'm getting this last term, right? Means I can take these factors for further simplification, right? These are the perfect factors because I'm getting middle factor, so I'm getting last middle term also, and I'm getting last term also. So I can use these factors for rearranging. Okay, so let us take this factor for further simplification. Okay, so after when I'm taking these factors, how I'll use this factor? See, x square minus 10x plus 5x minus 50 is equal to 0. Okay, now what will be our next step? What I'm taking now? I'm taking out x as a common. Yes, when I'm taking x as a common, what is the further remaining part? X minus 10. Okay, what is the common here? 5. 5 tens are 50. Okay, I'm taking out 5 as a common. So what I'm getting? 5 into x minus 10. 10 5s are 50. So this is how what I got. 5 into x minus 10. Okay, is equal to 0. Now, again, if you see, x minus 10 and x minus 10 is a common. So again, I'm taking out x minus 10 as a common. What is remaining? X plus 5. So I'm taking this as it is. X plus 5 is equal to 0. So this is how I'll get this equation. X minus 10 into x plus 5 is equal to 0. Now you know the property. Which property? If the product of two numbers is a 0, then at least one of them is 0. Okay, when you use this property, what will be our next step? You will write either x minus 10 is equal to 0 or x plus 5 is equal to 0. Right, now further simplification, what will you get? When minus 10 shift to the other side, what will you are going to get? You will get x is equal to 10. Yes, and when you shift this plus 5 to the other side, you will get x is equal to minus 5. Right? But what we are finding out? We are finding out score in the test. Score cannot be negative. So this minus 5 is unacceptable value, invalid value. So which value we are going to take? We are going to take x is equal to 10. What we are going to take? X is equal to 10. Okay. And what is x is equal to 10? X is equal to 10 is nothing but the score in the first stage. And what has been asked? They have asked score in the first stage itself. So last line, what will be your last line? The score of the Suresh in the first stage is the 10. Understood, students? Yes. In such a particular sums, you need to read these sums very carefully. Okay, everything is given in the sum itself. You have to first of all consider some variable, then you have to read carefully and what is exact condition given over here. According to that condition, you have to write the equation. Okay, you have according to that statement in the equation. Okay, according to the statement given in the equation or according to that condition, you have to form the equation. Okay, in a simpler form, that is, which is a simpler form? Ax square plus bx plus c is equal to 0. Okay, once you get the standard form, you can solve this quadratic equation by any convenient methods. Okay, and find out the solution of the equation. Once you find out the solution of that quadratic equation, and that is nothing but the what you exactly want in that particular sum. Okay. Okay, so let us move to the next slide. Okay, now we are reading sum number 6. Mr. Kasam runs a small business of making earthen pots. He makes certain number of pots on daily basis. Production cost of each pot is rupees 40 more than 10 times total number of pots he makes in one day. If production cost of all pots per day is a 600 rupees, find production cost of one pot and number of pots he makes per day. This particular question is of 4 marks. Okay, this generally asks in question number 4 or 5. Yes, logical question. Okay, based on your logic, you have to analyze this sum very carefully. Very simple sum it is. Mr. Kasam runs a small business of making earthen pots. So, which business Mr. Kasam actually runs? Of making earthen pots. He makes certain number of pots on daily basis. We don't know how many number of pots he's making daily basis. Okay. Now, production cost of each pot is rupees 40 more than 10 times total number of pots he makes one day. So, how will you find out the production cost of each pot? For that, we need to know total number of pots he makes in one day. Okay, once you know total number of pots he makes in one day, we can write what is the production cost of each pot. What is condition given over here? Production cost of each pot is rupees 40 more than 10 times the total number of pots he makes in one day. So if we assume total number of pots he makes in one day is X, okay, then we can find out production cost of each pot. What will be the production cost of each pot then? 10 times total number of pots. If total number of pots are X, what will be its 10 times 10X? Okay, 10 times of total number of pots means 10X plus rupees 40 more, and that will be the production cost, right? So you will get one condition over here. What will be the next condition given over here? The production cost of all the pots per day is rupees 600. Okay. Now what is given over here? Production cost of all the pots. In the first line, here what we have found out? Production cost of one pot only. Okay. Production of, in this line, what we have found out? Production cost of only one pot. Now in the next line, what is given? Production cost of all the pots. Production cost of all the pots in one day. Okay. Now if you know the production cost of one pot, you can easily find out production cost of all pots in one day, right? Yes. So what is necessary in this sum? You should read this sum very carefully. Everything is given in the sum itself. Only you have to read this sum carefully again and again till you are not understanding. Okay. So what is the last line? Find the production cost of one pot and number of pots he makes per day. Yes. What you would actually find out? Production cost of one pot and number of pots he makes per day. Now, what you have to first of all assume? You have to assume number of pots he makes per day. If you assume number of pots he makes per day is X. Production cost of one pot you will get from this condition. Yes. Yes, production cost of one pot will be 10 times total number of pots plus 40 rupees more, means X 10. Okay, 10X plus 40. That will be the production cost of one pot. Okay, so let us move to the next slide. Okay, what we are going to assume, first of all, Mr. Kasam make X number of pots on daily basis. Now, just now we have seen second line that production cost depend upon the total number of pots he makes per day or on the daily basis, right? What will be the production cost of per pot? Rupees 40 more than 10 times the total number of pots. Total number of pots are X. Its 10 time will be 10X and 40 rupees more. See, X will be the total number of pots he makes daily basis. 10 times is 10X plus 40 rupees 10, and that will be the production cost of each pot, right? So you will get production cost of each pot is 10X plus 40. Okay. Now what will be the next condition given over here? Production cost of all pots. Production cost of all pots per day is a 600. We know the production cost of each pot. Okay. But what is given in this condition? Production cost of all pots per day is a 600. Okay. We know the production cost of each pot and we know number of pots he makes every day. How many pots he makes every day? X. What is the cost of per pot? 10X plus 40, right? So you will get total number of pots he's making every day. Okay, you know total number of pots he's making every day. You know cost of each pot. Okay, so you will know cost of all pots he makes on daily basis, and that is nothing but the 600. See students, try to understand this sum. How many total number of pots are there? X is makes daily basis. What is the cost of each pot? 10X plus 40. Okay, so what will be the total cost of all pots he makes every day? x into 10x plus 40. Okay, and what will be the total cost? That will be nothing but the 600. So this is how you will get the second condition according to this line. Okay, production cost of all pots per day is equal to 600. Means here you have got this simpler form. Okay, now let us solve this equation. By further simplification, you will get this x into 10x plus 40 is equal to x into 10x, 10x square plus x into 40, 40 into x, 40x is equal to 600. Okay, now further simplification, what you are getting? 10x square plus 40x minus 600 is equal to 0. 600 when coming to this side become negative, right? Now let us move to the next slide. 10x square plus 40x minus 600 is equal to 0. Now you can see here 10 is common everywhere. 10 is common everywhere. So just divide both the sides of equation by 10. When you divide both the sides of the equation by 10, what you are getting? X square plus 40 divided by 10, 4 minus 600 divided by 10. What will you get? 60, right? See what I'm doing. Ten divided by 10. Okay, x square. This is how here what you are getting. X square. This x square, right? Plus 40x divided by 10. What will you get? 4x. Yes, 4x. Now what is there? Minus 600. Minus 600 divided by 10. So what you are getting? 60. That you are writing here, right? In this way, you should divide both the sides equation by 10, right? So what will you get? This equation you will get x square plus 4x minus 60 is equal to 0. So you will get x square. Now what is your duty? Yes, you have to further simplify this quadratic equation by finding out solution of this quadratic equation by either factorization method or by completing square method or formula method. Here I am using factorization method. Okay, so in the factorization method you need to know which is the middle term and what is the last term. Okay, what is the middle term? Plus 4. What is the last term? Minus 60. So find out the factors of the last term in a such a way that the factors which you are getting, when you are adding these factors, you are getting middle term, and when you are multiplying these factors, the product of these factors should be last term. Okay, so this is how I had taken these factors, that is 10 and 6, 10 and minus 6. So when I am taking this 10 and 6, 10 and minus 6, plus 10 minus 6 plus 4 I am getting, okay, and when I am multiplying 10 into minus 6, I am getting minus 60, right? Okay, see students, you need to know I am not taking minus sign for the 10. I am not taking minus sign for 10 here. Why? Because if I take minus sign for the 10 instead of giving minus sign to the 6, what will be a middle term? You will get middle term minus 4. But we want middle term as a plus 4, and that's why I'm not taking minus sign for the 10. Instead, I will take minus sign for the, I will give minus sign to the 6 and I will give plus sign to the 10 so that I'll get middle term as a positive. Okay. And when I multiply these two factors, I will get product as a minus 60. Okay. Now let us take these factors for further simplification. When I will take these factors, what I will get? x square plus 10x minus 6x minus 60 is equal to 0. Now, when you further simplify, what you are getting? See here, x is a common, x into x plus 10 minus, what is common over here? 6. So, what is common? 6 is common here. So, x 6 into x plus 10 is equal to 0. Now, if you can get confused over here. Here minus sign is there and how we are getting plus sign. See, look here, what we are doing. We are taking out minus 6 as a common, right? So, if you give, what I'm doing here, I'm taking out minus 6 as a common. Okay, so when you multiply this minus 6 with the plus 10, what you are getting? Minus 6 into plus 10 minus 60. Means you are getting minus 60. Okay, but still some students are getting confused while doing this step. Okay, what they are writing, no, instead of writing plus 10, they are writing x minus 10. And then in this case, you are not getting your common factor, which you should actually get x plus 10. Yes, so in this case, you don't get confused. What you do, you see what is the first factor over here. Here, what is the first factor? X plus 10. So blindly write here x plus 10. Okay, and then try to adjust. Yes, is it correct? Okay, then you can check whether it is correct or not. You have to multiply and 6. Multiply and check. Minus 6 into x minus 6x. Minus 6 and plus 10 becoming a minus 60 that you are getting here. So your confusion will get clear and you will not able to make any mistake in this way. So just write blindly here. X plus 10 is here. So you should write x plus 10. After writing, then try to check whether it is correct or not. Okay. Now we have corrected this, right? So this is how you will get this. Okay. Now what is the common here? X plus 10. So let us write this x plus 10 as a common. Okay. Now after this, what is the remaining behind? X minus 6 is equal to 0, right? Okay. Now, again, what you are getting here? This. Yes. X plus 10 in one bracket and x minus 6 in the another bracket. Now, which property you have to use? Yes. If the product of two numbers is a 0, then at least one of them is a 0. Okay, this property you have to use. When you use this property, what you are getting? Either x plus 10 is equal to 0 or x minus 6 is equal to 0, right? So after further simplification, what you are going to get here? Yes, x plus 10 is equal to 0 means what? When 10 will shift to the other side, it become minus. So you will get x is equal to minus 10. Okay. And when you shift this minus 6 to the other side, you will get x is equal to 6. Right. So what we are finding out? Number of pots. Number of pots cannot be negative. Right. Means this is an unacceptable value. Right. This is an unacceptable value. Which unacceptable value? Negative value. Number cannot be in negative. Right. So, what we are assuming or what we are taking as a correct value, x is equal to 6, right? So, number of pots, we are going to take, x is what? Number of pots. And what we are actually finding out? Production cost of each pot. Okay, what are the number of pots? X is equal to 6. What is the production cost of each pot? 10x plus 40. So let us multiply this. 10x means 10 into 6 plus 40. So further simplification, you will get 10 into 6, 60 plus 40, that is 100. So production cost of each pot is 100, right? So when you simplify this, you will get production cost of each pot is 100. So this is how you will get last step. And last line is a must. It carries half marks in board exam. So how will you write? The production cost of one pot is rupees 100. And the number of pots Mr. Kasam makes per day is 6. Means that is nothing but the x is equal to 6. I think student, you must have understood this. Again, I am telling you again and again, read the sum very carefully. Everything you will find in the sum itself. Yes, everything is given in the sum itself. Only you need to find out what is given in the sum. Okay, let us move to the next slide. Pratik takes 8 hours to travel 36 kilometers downstream and return to the same spot. The speed of boat in still water is 12 kilometers per hour. Find the speed of water current. This particular question carries 4 marks in board exam. Now, if you see this sum very carefully, it is of what time, distance, okay, it is of and speed, yes, kilometer and distance, yes. So it is about the physics. And again, if you read this sum very carefully, you can find out law of gravitation. Yes, Newton's law of gravitation you can apply here to solve this sum. Yes, Newton's. Earth attracts everything towards itself. Law of gravity. Do you know? Yes. Okay. So let us apply this. First of all, read this sum very carefully. Pratik takes 8 hours to travel 36 kilometers downstream and return to the same spot. The speed of the boat in still water is 12 kilometers per hour. Find the speed of water current. See, what you have to find out? Speed of the water current. Okay, so first of all, you need to assume speed of the water current is x kilometer per hour. See here, units use r in hours and kilometer. So you will assume the speed in kilometer per hour only, because unit should be uniform everywhere. You can't use units different. You can't use units different here. Okay, somewhere you can't use minutes, somewhere you can't use second. Everywhere, if you are keeping units, are everywhere you should keep uniform only. Okay, so which unit we are using for the time, hours, and for the distance we are using kilometer, right? This is clear. Okay, now first line, concentrate on the first line. Pratik takes 8 hours to travel 36 kilometers downstream and return to the same spot. Okay, so here which distance we are going to consider? Downstream and upstream. Okay, so look here, distance is going to remain same only. Which distance? 36 kilometers. Which distance? 36 kilometers. Downstream 36 kilometers, and while returning to the upstream, which distance? 36 kilometers. Means distance is going to remain same only. And how much time Pratik takes? Pratik takes 8 hours to travel 36 kilometers downstream and return to the same spot. Means total for coming and down. Okay, for going down and again coming back to the up, it will take how much time? 8 hours. Total for downstream and for upstream, total how much time Pratik takes? 8 hours, right? Okay, now concentrate on the next line. The speed of the boat in still water is 12 kilometers per hour. Now, what is the speed of the boat in still water? Still water means steady water. It is not a running water. It is a still water. What is the speed of the boat in still water? Yes, 12 kilometers per hour, right? Okay. Now, what we have to find out? Speed of the water current. Okay. Now, let us concentrate on what you have to find out in this speed of the water current. Okay, now let us assume the speed of the water current be x kilometer per hour. Now, if you concentrate on this line, what has been given? The speed of the speed of the boat in still water is 12 kilometers per hour. So let us first of all write what is given in the sum. Speed of the boat is 12 kilometers per hour. Okay. Now, what is your next duty? You have to apply Newton's law of gravity. See, earth attracts everything towards itself. Yes. So whenever any object comes down, what is happening? Gravity. Because of the gravity, the speed of the object increases. Yes. So whenever, for example, I'm giving you an example of the ball. When you're throwing up, okay, it is going against the gravity. So obviously the speed of the ball will decrease, right? But when it will come down because of the effect of the gravity, the speed of the ball will increase. The same case or same law we have to apply here. Okay, while coming down in a downstream, the speed of the boat will increase, right? But while in upstream, when this boat will going against, okay, in upstream against of the water stream, obviously it is going what against of the gravity, so speed of the boat will decrease while going up. Are you understanding, students? Here we need to apply the law of gravity. Okay, earth attracts everything towards itself, so obviously in downstream while going down, the speed of the boat will increase. But when going in upstream, since it is going against of the gravity, the speed of the boat will decrease. I think, student, you must have understood what is given over here. The speed of the boat in still water is 12 kilometer, right? So in a downstream, okay, downstream speed of the boat will increase. So its speed of the boat will be 12 plus x. Okay, speed of the water current is x kilometer. Speed of the boat is 12 kilometer per hour. So when in downstream, it will add 12 plus x. The speed of the boat will be 12 plus x because it is going to increase. Okay, and what will be the speed of the boat in upstream? It will decrease. Let us see in the next slide. See, speed of the boat is more than water current while it is going down, means in downstream. Okay, now in this, so that's why we are written x is lesser than 12. What is x? X is the speed of the water current. What is a 12? 12 is the speed of the boat. Okay, so in a downstream speed of the boat is more than water current because it is coming down. Speed of the boat will increase since it is coming towards the effect of the gravity. It is coming by the effect of the gravity. So the speed of the boat will increase, and that's why the 12 will be more than or greater than x. Okay, so what will you write? The speed of the boat in upstream. Upstream, obviously the speed of the boat will decrease. So you will write 12 minus x. What is a 12? 12 is a speed of the boat. And what is the x? Speed of the water current. While going up, the speed of the boat will decrease, and that's why you are subtracting x from 12. 12 is the speed of the boat. Okay, and x is the speed of the water current. While going up, the speed of the boat will decrease, and that's why you are subtracting the speed of the water current from the speed of the boat while going up. And while coming up, the speed of the boat will, while coming down, speed of the boat will increase, and that's why you are adding x, that is a speed of the water current in the speed of the boat. Understood, Shreya? I think you must have understood. Again, you need to read this sum again and again, then only you will more clearly understand this. Okay, now which other formula we are going to use here? Time is equal to distance upon speed. Okay, time is the time gap is going over here. Distance is kept over constant. Which distance? 36 kilometer. Okay, while going up and while coming down, the distance is going to same only. That is 36 kilometer. Yes, understood. Only speed is going to vary. Okay, while coming down, speed will increase, and while coming up, the speed will decrease. Yes, but total distance going to remain same only. Okay, now let us see. Use this formula to find out time for the upstream and to find out time for the downstream. Okay, time required to cover 36 kilometer upstream. What we are writing, which formula you are using? 36. See, distance is going to remain same, that is 36. What is the speed in upstream? What is the speed in upstream? 12 minus x. So this is how we got time in the upstream as 36 upon 12 minus x hours, right? Now let us find out time required to cover distance. 36 kilometer is constant, but where we are finding out for the downstream, right? Downstream, again, we are using which formula? Time is equal to distance upon speed. Distance is going to remain same, that is 36, right? But speed which is speed 12 plus x. So this is how you will get time in upstream and downstream. Now you are having time for the upstream also, downstream also, right? But what is the condition given? Total time to go up and down, means total time to go upstream and downstream is a what? 8 hours. Okay, so what will be going to write in the next slide? Time required to cover upstream plus time required to cover downstream is equal to total timing. What is the total timing given here? 8 hours. If you read first line of the sum, you will clearly understand total time required to cover the upstream and downstream is 8 hours. So let us add this time for the downstream and upstream, okay, in the next slide. Okay. So according to the given condition, time taken by the Pratik to go and return the same spot is a 8 hour, right? So let us add this as a 8. Okay, when you simplify this, you will get quadratic equation. Okay, very simply it is. See, look here, the denominator is different here. So first of all, you need to equalize this. So let us further simplify this. See, look here. Here you can see 36 is a common. Okay. So we have taken out 36 as a common in this step. Okay. Now, what is the next step? We have to equalize the denominator. Okay. So equalize means you have to multiply. Okay. Now, first of all, you shift this 36 to the other side. Okay. So it become 8 upon 36. Here it is up. So when it will go to the other side, it will come down. Right. Now, let us equalize this denominator. So what will be our denominator? 12x into 12 plus x. Okay, just cross multiply here. 12 plus x will come here and 12 minus x will go here. So this is how you will get numerator as 12 plus x plus in the another bracket 12 minus x, right? Divided by 12 minus x into 12 plus x. Okay, when you do this, a divided by 36, what you are going to get? Yes, 2 nines are 2 divided by 9, right? Okay, now let us concentrate on the next line. Okay, here you can use this formula, a plus b into a minus b. You have to use this formula. So what will you get? This a square minus b square. Okay, here a is a 12 and b is a x. So this is how, what is a square? A square is a 12, that is a 12 square, that is 144 minus b square. B is a x, so minus x square. Okay, when you simplify this to the numerator, you will get 12 plus 12. What? 12 plus 12, 24, and this x will get cancelled. So this is how you will get 24 divided by 144 minus x square is equal to 2 upon 9, right? Okay, now when you further simplify, see, look here, you have to cross multiply here. 24 into x is equal to 2 into, in bracket, 144 minus x square. When you further simplify, you will get this 24 into 9, 216 is equal to 2 into 144, that is nothing but 288 minus 2x square. Okay, let us find out this by further simplification. When you shift minus 2x square to the other side, you will get 2x square is equal to 288 minus 216. 216, when you are shifting to the other side, it becomes minus, right? So you will get this 2x square is equal to 72. See, 288 minus 216 becoming 72. So when 2 will go to the other side, you will get 36. 36 2s are 72. But you are getting value as a plus minus because you are finding out what? Square root of the 36. So when you are finding out square root, you are getting either plus or minus value. Again, you are not going to take negative value. Negative value is an unacceptable value. Why? Because we are finding out speed, and speed cannot be negative, right? So let us take x as a positive. Let us take speed as a positive. Okay, and x is nothing but what? Speed of the water current. Okay, so what we have found out? Speed of the water current. Okay, so last line will be the speed of the water current is just 6 km/h. I think student, this sum is a very simple sum. Only you have to read this sum very carefully. You have to see which formulas are given about speed, distance, time. You have to see the units. You have to apply the law of gravity. You have to see what is the speed in downstream, what is the speed in the upstream, which distance is given, and what is going to remain same. Everything you have to read very carefully. You have to apply some physics laws here, and you have to solve this sum. I think you must have understood, students. Thank you, students. Hello. Hello. Hello, ma'am.
Hello, ma'am.
Yes, time is over. Can I leave?
Yeah. Thank you, ma'am.
Yes.
Students, stay continued for the next lecture. Sneha, ma'am.
Yes, ma'am. Good morning.
Very good morning. Can we start immediately?
Yes, ma'am. No issue. Just give me 2 seconds. Let me share the screen.
Yes. Okay.
Yes, ma'am. Shall I start?
Okay. Yes.
Hello, students. Good morning. Good morning, everyone. Here I am Sneha Singh, your history teacher. I hope you didn't forget me. You remember me. Yes. I hope all are doing fine. All are studying at home and reading the textbook, preparing the notes. Right, students? I know you won't disappoint me. Yes. So let's start with our chapter, sixth chapter, entertainment and history. So for this, as usual, every time I tell you all to do, take out your textbook, take out your notebook, pen or pencil, however you're comfortable. Just take out that and let's start with the chapter. Yes, students, every time I observe that you never write the doubts, you never note down the doubts, because I have never seen you asking the doubts. Hardly 1 or 2 students ask the doubt. Yes, so please take out your notebook and please write it down, the doubts. Whenever I'm explaining anything which you didn't understand, that please write it down. Okay, so we'll start with the chapter today. We will finish it off, this chapter. Yes, so here let's have a quick recap of till now what we have completed in this chapter. Let's see to it. Yes, first we have done why do we need entertainment? Why? Because of the, because healthy entertainment is an excellent quality which is essential for the healthy growth. If you want to develop your personality, then healthy entertainment is very, very important. And here in India, we have so many varieties, so many activities, dance, music, and all, which gives you the healthy entertainment, right? Then the next one, it was folk theater. That is the puppet shows in Hindi, which is known as the Katputli. We completed that. In that, we have seen the roots, the history of the puppets we got from the as well as from the sites of the Egypt and Greece, right? Then the next one, the puppetry shows, that is the two styles. One is found in the Rajasthan and the other one is found in the southern region of India, right? And the most important role which is in the puppet shows, which is by the Sutradhar. Sutradhar, who is Sutradhar? Narrator is the Sutradhar. The story, the person who narrates the entire show is the Sutradhar, narrator, right? Then we have seen the 4 types of puppets, the 4 types of puppet shows. That is a shadow puppet. Shadow puppet, that is the shadow of the puppet is shown. Puppet is kept behind the curtains, right? Which is also very interesting. Then the hand puppet. The puppets are made, and which is with the help of the movements of the hands and all, this puppets shows are shown. Then the string puppet, the string is tied in the puppet's hand and all, and the movement, they keep on moving it, and with the help of that it shows. Then the wooden puppet. These are the 4 types of puppets we have seen. Then another type of theater, that is a Dashavatara theater, which is a folk theater in Maharashtra. And here in Dashavatara theater, basically they deal with the stories of Lord Vishnu, the 10 incarnations of Vishnu. Incarnation means avatar. Here there is a 10 name of the Vishnu's avatar name. That is a Dashavatara theater. Bhajan, that is a devotional song. There are 3 types of bhajan. We completed it. Then Kirtan. After Kirtan, we completed the Lalit. Then Bharut. Then Tamasha. Povda. Then Marathi theater. Till last, in our previous lecture, we completed till Marathi theater. Now, today, we will start from the Indian film industry. Yes, students. Very, very interesting. Indian film industry. Everyone knows about it. Today you see that so many technologies, so many cameras, VFX, this effect, that effect. Means so many updated technology has come. Now, nothing is impossible to show. Nothing is impossible to prepare or make. Anything they can show with the help of the technology, right? Nowadays, you see colorful TV with visual also, with images also. But when the film industry started, it was very difficult to start the picture also and audio also, both. Yes, either it was possible that either they can show the moving images like video kind of, or they can show the sound. Both was not possible, right, students? But slowly, this became possible. Let's have a look on it. We will do it. Here. cinema is a medium that brings together art and technology. With the technology of motion pictures, the film industry came into being. It gave rise to the era of silent movies. Later, the technology of sound recording was introduced and the age of sound movies began. Yes, students, here in this part 6.4, Indian film industry, in that person, cinema. Now, what is cinema? Students, till now we have seen the tamasha, the drama, the Marathi theater, all that play, right? So in that, it is only the concept of art. There is no role of technology. Yes, they are the artists are doing their job. Artists are doing the acting. Artists are showing the concept stories. But where is the technology over there? There is no technology, right? So here that technology, cinema is a medium where art, it is a combination of art and technology both. In theater, if one time they will do the play, one time audience will see. But in movies, in cinema, if one time they will do acting, like n number of times people can watch that, right? So that is the combination of art and technology. So with the technology of motion pictures, the film industry came into being. So when the technology of motion pictures, yes, students, many of you all might have seen that in the movie Tare Zameen Pe. In that, the child is having that book. When he is just moving the pages, you can see that one image is moving. Yaad aaya sabko? One object, the child is moving far away from the parents, right? So here, that time, the concept of video was like this only. It was not the video, it was the moving object. That is, one object is moving, so that becomes the video kind of. So it became the concept of motion pictures. The film industry came into being, and this gave rise to the silent movies. Yes, students, silent movies. Why? Because that time it was not possible to add the audio with the motion picture. Pictures are moving, audio कैसे उसमें add करेंगे? Right? So here, that is why it became the silent picture. It became the silent movies. Means no audio. You can see only the actors, actresses are acting. They are just acting. They are creating the humor. They are making the people laugh. They are making the people emotional. Only with the help of acting. No voice, nothing. Yes. Later, the technology of sound recording was introduced and the age of sound movies began. So, this one, after the silent pictures, later, काफी time के बाद, the sound recording, the concept of sound recording came. That now with the images, you can add sound also. Just you think about it, that without sound, how difficult it was to make a hit movie. Okay, now let's move on it. The honor of making and releasing the first full-length movie goes to the Maharashtra. Maharashtra is known as the land that nurtured the Indian film industry. The contribution of Madan Rao Madhav Rao Pitale, the Patwardhan family of Kalyan, Harishchandra Sakharam Bhattovdekar, also known as the Save Dada, is very important in the development of Indian movies. Students, please mark this, the names of these great personalities. Mark it that. It can be the answer the following in one sentence or in the objective or in the long answers also, it will help you. So please mark that, right? So the honor of making and releasing the first full-length movie goes to Maharashtra. Yes, students, you should feel proud that till now, no other state was ahead in this. The first state was Maharashtra. Maharashtra made the first full-length movie. That is why Maharashtra is known as the land of nurtured. The Maharashtra is known as the land that nurtured the Indian film industry. That is why, all the Bollywood stars stays in Mumbai. Maharashtra is known as the land that nurtured Indian film industry. The contribution, who contributed in this? Which great personalities was there in the contribution? That is contribution of Madan Rao Madhav Rao Pitale. Now, who was this? He was the Patwardhan family of Kalyan. He belongs to that. Then Harishchandra Sakharam Bhatavdekar, also known as Save Dada, is very important in the development of Indian movies. So the first name, what you will write, that is the Madan Rao Madhav Rao. He played a great role in this, the key role, which was from the Patwardhan family. And the second, you are going to write the Harishchandra Sakharam Bhatavdekar, right? Who is well known by the name Save Dada. Now, next one. Later, Gopal Ramchandra Torane, also known as Dada Saheb Torane, and A.P. Karandikar, S.N. Patankar, V.P. Divekar, sought help from the foreign technicians and made a movie entitled as Pundalik. It was released in the Mumbai in 1912. Raja Harishchandra movie directed by Dada Saheb Phalke was the first to be processed completely in India. It was released in Mumbai in 1913. Right? So here, students, that is later on after this one first full-length movie, right? After that movie, the another personality, Gopal Ramchandra Torane. Okay, Torane, he known as the Dada Saheb Torane. No, not Dada Saheb Phalke. Okay, Dada Saheb Torane and A.P. Karandikar and S.N. Patankar, V.P. Divekar, all these great personalities, they came together and they took help from the foreign technicians. Yes, students, before our Bollywood movies or Indian movies, they were developed. Before that, foreign cinemas, the foreign countries were far ahead from us in making movies and all. So they took help from the foreign technician and made a movie entitled as Pundalik. The name of the movie is Pundalik, which was made with the help of foreign technician. It was released in Mumbai in which year? 1912. Yes, students, you can get them as the following, in which one side the names of the movie is written and the other side the name of the year is written. Yes, you have to write that. Then Raja Harishchandra movie directed by Dada Saheb Phalke was the first to be processed completely in India. Yes, students, everyone might have heard the name Dada Saheb Phalke. The award also, the biggest award in Bollywood, that is the Dada Saheb Phalke Award. Selective people get this award, not everyone. Right? So he was the first person who made a complete movie. The full process was done in India. And what was the name of that movie? The name of the movie was Raja Harishchandra. Yes, students, please remember that first movie which was completely processed in India, Raja Harishchandra by Dada Saheb Phalke, which was released in Mumbai in which year? 1913. Yes, before the World War I. He also created silent movies named as Mohini Bhasmasur. Silent movie, that is no voice, only picture. So the first one was the Mohini Bhasmasur. Then the second one, Savitri Satyavana. Also the documentaries on the rock-cut caves of Verul and pilgrim centers of Nasik and Trambakeshwar. Yes, students, the places which is in Maharashtra. Rock cut caves, Verul, very beautiful cave it is. Pilgrim Center, Nasik, and Trambakeshwar. Trambakeshwar comes, it's Lord Shiva temple, yes, which is in Nasik. So he made the documentary on that also. Students, if you all are not aware about what is documentary, so let me tell you a short film, which is on the, it is a informative movie. Suppose rock documentary on a rock cut cave. It just gives you full information of rock cut cave, the history also and the current scenario also. Okay. Then later a tradition of making movies on a historical and mythological subject came to being. Historical movie like, for example, Rock Cut Cave. Rock Cut Cave at Verul, if we will make movie on that, it is a historical movie. And if the movie is on Bhasmasur or Savitri and Satyavan, that is a mythological story. Yes, suppose now also this one, suppose a movie on Ramayana. Movie on Ramayana, so again it is mythological, right? So mythological means a story which is related to the god and the goddesses, and historical, that is related to our ancestors, our past, our history, that is. So slowly, the first one, which type of movie came into being? It came, that is a mythological and a historical movie. Here on the slide, the image you can see, that is the image of the, on the left hand side, that is a small image of the movie Raja Harishchandra, the person you can see, yes, with mustache and all, the Raja Harishchandra. Right hand side, that is the image of the Dada Saheb Phalke. Okay, then the next one, Anand Rao Painter, the first one to make cine camera of Indian make, also got interested in making movies. His cousin Babu Rao Painter is also known as Mistri, made Sairandhri in 1918. He made the first historical movie, Simhagad, which was a silent one. He also created historical movies like Kalyancha Khajina. Then next one, Baji Prabhu Deshpande and Netaji Palkar. He also made a movie on a realistic social issues entitled as Savakari Pash. In 1925, Balaji Pendarkar made a movie entitled Bajirao Mastani. However, the British government suspected it to be a medium of spreading nationalistic sentiments and it was banned. Yes, students, if you have focused the year 1913, 1914, 1918, all these are the during the British rule before independence. Yes, so here the Anand Rao Painter, he was the first person who made the cine camera. Cine camera, this is the camera which is used for the recording for the cinema purpose, and that was very expensive also. And then slowly got interested in making movies. So first, Anand Rao Painter, what he did, he first made the cine camera and then he involved in making movies. And also his cousin Babu Rao Painter, also known as a Mistri, he made the movie on Sairandhri. The movie named Sairandhri in the year 1980. And he made the first historical movie Simhagad. Yes, as I said, that time the trend was about the mythological movie and the historical movie. So he made a historical movie on Simhagad, which was a silent one. Again, the silent one means there was no audio, only the images was there. Yes. He also created historical movies, Kalyancha Khajina, Baji Prabhu Deshpande, Netaji Palkar, who, that is his cousin, this one, Anand Rao Painter's cousin, Babu Rao Painter. He made all these movies, yes. And he also made on the realistic issue. Till now, he was making the movies on the historical concept. Now he moved on to social issues. Social issues, that is a Savakari Pash. Then next one, in 1925, Balaji Pendarkar movie named as the Bajirao Mastani. This was very beautiful movie Yes. So don't think about the this one, the Bajirao Mastani, which was released this one soon. Deepika Padukone and Deepika. Yes, Deepika was only there, na? Yes, yes, yes. Not that movie. Okay, this is a different one. However, now with this movie, with the historical concepts movie, and this one, historical concepts, social issues, mythological concept. Now, what Britishers started thinking? Britishers started thinking that these people are creating the nationalistic sentiments. They are spreading nationalism. They got too much scared. कि अरे अब क्या होगा? Now if everyone, because Britishers concept was there, na, divide and rule. So that is why they were worried. If all the Indians will come together, if such problems started, if all the people started coming together, it will create problem to us, right? So that is why they wanted to divide and rule. Yes. Now, the next one, Kamlabai Mangarkar was the first woman producer. Yes, students, please underline that. Kamlabai Mangarkar was the first woman producer. She produced Kavalya Tandel and Pannadai, Hindi. In Hindi, it is a Hindi movie. Then the Ram Shastri, a movie made by the Prabhat Company in 1944, became very popular. Then in post-independence period, yes, till now it was a pre-independence period, that is before independence period, before 1947. Now we will talk about the post-independence period, that is the after independence period. Few movies were made on the historical themes, like Acharya Atre made a movie on the life of the Mahatma Phule, and Vishram Bedekar made movie on the life of the Vasudev Balwant Phadke. Dinakar D. Patil made a movie entitled on the Danya Te Santaji Dhanaji Bal Shivaji. The movie made by Prabhakar Pendarkar also need a special mention. Yes, here are a few movies that was made after the independence. That is here we can find the first woman producer name. Then the Ram Shastri movie, which was made by the Prabhat Company. Then Acharya Atre made a movie on the great personalities of Mahatma Phule and Vishram Bedekar. Yes. Then historical movies were also made in Hindi. The Hindi movies made in the pre-independence period, that is Sikandar, Tansen, Samrat Chandragupta, Prithvi Vallabh, and Mughal-e-Azam were made a historical backdrop. Dr. Kotani's Ki Amar Kahani. Dr. Kotani's Ki Amar Kahani is a true story. The movie is based on the Indian struggle for independence, such as Andolan, Jhansi Ki Rani, also deserves a mention. Yes, after independence, what happened? Movies started coming up on the historical issues, on the historical concept, about the historical great personalities who fought for the independence. Yes, Sikandar, not the person who fought for the independence, he was the invader. Then Tansen was the one of the Ratna in the Akbar's Darbar. Then Chandragupta, Samrat Chandragupta, the founder of Mauryan Empire. Everyone is aware about that. Yes, and Mughal-e-Azam, that is again, Mughal-e-Azam was such a big hit movie. Earlier it was in the black and white. Yes, earlier that audio to rehta hi nahi tha, but simultaneously there was no color also. Only two colors you can find in the picture, that is black and white. Yes. So again, Mughal-e-Azam people loved it so much that in color it was made. And Dr. Kotnis Ki Amar Kahani, that is a true story. Yes, and the struggle of independence by the various people. All these. Production studios such as Bombay Talkies, Rajkamal Production, RK Studios, now Ketan, etc., played a significant role in the development of the Indian film industry. Yes, students, that now if you want to make the movie, then you have to have the studios also. The famous studios and the oldest studio, that is the Bombay Talkies, Rajkamal's Production, RK Studio. RK Studio is at Chembur. Yes, that is Raj. It belongs to the Raj Kapoor family and the Kapoor family. Then now Ketan, etc., played a significant role in development of Indian history. So till now we were seeing the cinema part. Now let's have a study about the entertainment and the professional opportunities. Like in the media chapter, we have also seen that the this one. Okay, all these are the features, aspects, varieties, and all. But what are the opportunities in that? Now let's see the opportunities which is there in the cinema. Students of history can avail many professional opportunities in the fields of the drama and the movies. In drama, what opportunities are there? In order to achieve accuracy of stage backdrop on the stage, deep knowledge of the history of art and architecture of the concerned period is essential. Experts in these fields can work as an art director or consultant. Yes, in drama, in this chapter, two parts we have seen the drama also and the cinema also. First, what are the opportunities which are available in the drama? In drama, that is in order to achieve the accuracy, if you want to show the perfect concept of history, then the stage backdrop, that is setup of the stage, should be perfect according to the story. So for that, the knowledge of history is very, very essential, very important. That what was the stage backdrop, what was the setup, what is the color, what is the where. Suppose, for example, you are showing any war. So what was the backdrop of that war on the stage? So all these are very, very important. Architecture of the concerned period is essential. Expert in these fields can work as an art director or the consultant. Yes, so here the person who is from the history background, they can direct the concept, or they can become the consultant also. The next opportunity which is available, the script writers as well as the dialogue writers need assistance of the experts in languages and the history of languages, as well as the experts in the cultural history of given period. Yes. Now, after the backdrop of the stage, the story, the scripture is also important. Now, the persons of the history background, what they will do? They will, the script writers, they will give the dialogue, and here the artists also need the assistance in the language of and the history of languages. It's not that right now if you are speaking the you can speak English, so the drama is also conducted in English. No, if you want to make it really realistic, you have to follow the language spoken dialect. Yes. So the first one will be the backdrop of the stage, and this will be in the script of scripture and the dialogue and the language. All these are very important opportunities which is available in drama and cinema. The director of the movies create the backdrop design of the atmosphere, costume, jewelry, makes up the hairstyles, etc. The theme of the movie, scholars of the history can work in these as an art director, as a consultant to the art director. Hello, ma'am, am I audible? Hello.
Yes, ma'am.
Sorry, actually due to network issue, I got disconnect.
Okay. But you are the co-host.
Yes.
You can
Yes,
continue. Yes, you can continue. No problem.
Yes. Yes. So, like in drama also, in cinema, creating the atmosphere, that how was the atmosphere of that time, how was the costume, how was the jewelry. Yes, because if suppose for example one of the movie of Hrithik Roshan, Mohenjo-daro, right, that was totally yes. So if you are showing the Mughal Azam story, so the costume and the jewelry becomes different. And if you are showing the British's time history, then again the costume and the jewelry becomes different, right? Hairstyles and all that. So that is why all these things should be properly precise and directed by the the person who is having the history knowledge. And again, the same thing, the dialogue, the knowledge of the culture, language spoken is to be consulted by the historian. Experts in this field can find many opportunities. Yes. So in cinema also, in drama also, the opportunities are similar. Slight differences is there. Yes. Right. So here we completed our chapter, entertainment and history. Yes, students. So let's have this one, doubts. Let me solve your doubts. Yes, Khushi Kanodia, Arsh Qureshi, Shivam Pandey. Yes, please unmute yourself and ask the question. Any doubts? Because here we will complete our chapter. Any doubt, any question? Yes. Arsh, what's your question, my dear? Please ask, unmute yourself and ask your question.
Nothing, ma'am.
Nothing, you have raised your hand. No doubt. Arjun? Yes, dear. What's your question? Please unmute yourself and ask. Arjun? Rizwan? No one is having any doubt? Yes? Okay. So, okay, fine. I'm giving you all 5 minutes. Let's have a quick revision what we completed in this chapter. Yes, we have seen the need of entertainment. Why do we need entertainment? Yes. Then in the entertainment part only, we have seen the active entertainment and the passive entertainment. Active entertainment means where your hand and mind both are involved. You're actively participating. You're doing also, hand and mind coordination is there. Like for example, painting, playing sports. Yes, all these are the active entertainment. And dancing also, singing also, right? And the passive entertainment means reading book, watching movies, listening music, watching dance. All these are the passive entertainment. Yes, we completed that. Then we have seen the folk theater. Folk theater, that is a puppetry, which is also known as Katputli. We have seen the 4 types of Katputli. Then we studied the concept of Dashavatara theater. Then we completed bhajan. There are 3 types of bhajan: Chakri bhajan, Tungi bhajan. then Khanjiri Bhajan, yes, then Kirtan. After Kirtan, we completed Lalit, then Bharud, then Tamasha, Kovda, Marathi theatre. Then we completed Indian film industry, which we did today. In Indian film industry, then the professional opportunities which are involved, drama, and in cinema as well. Okay, so students, here is your assignment which you have to complete. It is very interesting. You will enjoy doing that. You have to find out the names of the historical. Last time I have given the Marathi movies, but this time I will give you the Bollywood movies only. From 1970 till now, till 2015, write down the list of historical movies, the movies which is based on history. All that we have to we have to find. Yes, complete that and please submit it to your respective teachers. Yes, and you all don't have doubt. That is, I'm confused why you don't have doubt. Yes. So if you don't have doubt, okay, no question, no doubt. Ma'am, shall we stop over here? Hello, ma'am.
Yes.
Yes, ma'am. Shall we stop?
Yes, we'll stop here.
Okay, ma'am. Thank you. Thank you, students. Please study and complete your assignment. Okay. Bye. Take care.
Thank you, ma'am. Thank you so much.
Yes, thank you, ma'am.
Students, stay continued for science lecture with your textbooks and notebooks. And again, a reminder for you all students, please rename your name properly with your school name. I don't want any rubbish names. Just now I removed one student who had a very rubbish name, which I saw just now. I removed that student. So please, your name and your school name. I don't want any rubbish nonsense names seen over here. Rohit sir, very good morning. Hello.
Good morning. Good morning, ma'am.
Yeah,
Good
please.
morning, ma'am. Okay, okay.
Hello, sir.
Hello, ma'am.
Yes, can we start?
Yes, ma'am. Okay.
Yes.
Hello, good morning. Hello, good morning to everyone. Once again, I welcome you for today's session. Myself, Rohit Kulkarni. As all of you know, we are going to see topic number 5, heat of science 1. So, all it's my request to everyone that you can open page number 62, lesson number 5, heat. Now, before beginning the lesson, just I want to tell you that what are the points we are going to see in this lesson. Now, see, we are going to identify heat as a form of energy. Then, to investigate the effect of heat on solid, liquids, and gases. We'll distinguish between the temperature and heat, and the students will explain specific heat and describe how it differs from substance to substance. So, these are some of the points we are going to study in today's session. Right now, before, if you see on page number 62, there's the first question is asked that what is difference between heat and temperature? Now, before going to that question, just I want to tell you one thing that all of you know that matter exists in 3 forms, that is solid, liquid, and gases. Now, if you see, the first question is asked, what is the difference between heat and temperature? Right. So first we'll see this question. Now, the heat is what? It is one form of energy. Particles of matter, such as atoms, molecules, etc. It possesses both potential energy as well as kinetic energy. Total energy of all the particles of matter in a given sample is called its thermal energy. Right? In short, what you should know that heat is what? Heat is one form of energy, and temperature is what? It is a quantitative measure of degree of hotness or coldness of a body. Means when we measure the temperature of any object, what we understand whether the object is hot or whether the body is hot or cold. So as you know, it is expressed in either degree Celsius, degree Fahrenheit, or Kelvin. So these are the units. And mostly temperature, what it does, it determines the direction of energy transfer. Right? So this is the difference between heat and temperature. So heat is one form of energy, and temperature is what? It is a quantitative measure of degree of hotness or coldness of a body. Clear? Now, if you see the second question, what are the different ways of heat transfer? Now, there are 3 different ways, so you can write down the answer. The first one is conduction, convection, and radiation. So these are the different ways of heat transfer: conduction, convection, and radiation. In the previous standard, we have learned about heat and different types of heat transfer. We have also performed few experiments related to expansion and contraction of solid, liquid, and gases. Right? So you can see 3 different ways of heat transfers are shown in the slide, that is conduction, convection, and radiation. So we have learned about the difference between heat and temperature. We have also seen how temperature is measured using a thermometer. Now, different concepts like latent heat of phase transformation, anomalous behavior of water, dew point, humidity, specific heat capacity, etc., are related to certain phenomenon experienced by us in our day-to-day life. Let us learn more about this concept. Now we are going to begin our main point. So the first point of the topic is latent heat. So to begin with, we will see one activity which is given on page number 62. Now first we'll go through the activity. If you see in slide, one diagram is shown. The diagram is related to the same activity, that is latent heat. Now see what are the things required. Take a few pieces of ice in a glass beaker as shown in the figure. Right, so what we are going to take, we are going to take one beaker, and in beaker we are going to add some ice pieces of ice. Then insert the bulb of a thermometer in ice and measure its temperature. So with the help of thermometer, we are going to measure its temperature. Put the beaker on a stand and heat the ice using a burner. So whatever that beaker is there in which pieces of ice are there. So the beaker we are going to heat on putting on the burner. Record the temperature using the thermometer after every minute. So this is the most important point, that when we are heating that ice cube, we are going to measure the thermometer after every minute and we are going to note it. As the ice is heated, it starts melting. Stir the mixture of ice and water, right? So as we are heating the ice, so what will happen after few minutes, it will start melting. As it melts, we are going to mix the mixture of ice and water. Continue the heating even after ice starts melting. Clear? Draw a graph temperature versus time. So that we'll see afterwards how to draw a graph. Now this is an activity what we have to do. Now after doing this activity, we'll see what are the things. Now see, you will observe that the temperature of the mixture remains 0 degrees Celsius till the ice melts completely, right? Now initially what happens when we are doing this activity, we will notice that the temperature of the mixture, it will remain 0 degrees Celsius till the ice melts completely. As ice melts completely, till that the temperature will be 0 degrees Celsius. If we continue heating and still we are heating the same mixture, even after conversion of all the ice into water, the temperature of water starts rising and reaches 100 degrees Celsius. So see what happens afterwards. So if we are heating it continuously, whatever the ice is there, it will convert into water, and the temperature of the water, it will start rising and it will reach near up to 100 degrees Celsius. At this temperature, water starts converting into steam. The temperature of water remains constant at 100 degrees Celsius till all water converts into steam. Now, as all the ice starts converting to water, the temperature will reach up to 100 degrees Celsius. And what will happen? The temperature will not increase further. It will remain constant at 100 degrees Celsius, and whatever the water is there, it will start converting into steam. Now, if you see on the next page, the graph is given. The graph of temperature versus time, it is shown. Now, if you see in the slide, we have one graph of temperature versus time. So we'll see that graph. In this graph, line AB represents conversion of ice into water at constant temperature. Now just look where it is AB is written. If you see at the bottom on the x-axis, the AB is there. Now what the line AB represents? It represents conversion of ice into water at a constant temperature. Means initially the ice will convert into water as we start heating. When ice is heated, it melts at 0 degrees Celsius and converts into water at this constant temperature. So when ice is heated, it will start melting at 0 degrees Celsius, and slowly what will happen? It will convert into water. Now what happens actually? The ice absorbs heat energy during this transition, and the absorption of energy continues till all the ice converts into water. So as we are heating, we are giving external heat. So what happens? The ice absorbs the heat energy and it converts into water. So during this transformation or during this transition, the absorption of energy continues and all the ice converts into water. Clear? So this is the activity, right? Further we'll go to that. Now before that, you can see the time and temperature, because after each minute we are going to, now here you can see the time duration we have taken 2 minutes. So initially the temperature will be 0. After 2 minutes, 4 minutes, this temperature is 0. But as we are heating it, as the time is increasing, you will see that after half an hour, nearly about after 20 minutes, the temperature of the water, of the ice, goes up to 100 degrees Celsius. But after that also, means after completion of 22 minutes, 24, 26, or even further half an hour, the temperature remains constant, that is 100 degrees Celsius. It will not move further. Clear? So this is the activity about latent heat. Now, see, the temperature remains constant during this transition. This constant temperature at which the ice converts into water is called the melting point of ice, right? If you have textbook, you can underline the definition for that. The constant temperature at which the ice converts into water is called the melting point of ice. Or the same definition you can write, the temperature at which a solid substance melts and changes into a liquid at atmospheric pressure is called as melting point. So any definition you can write. Clear? So this is the first point about melting point. Now we'll see further about boiling point. Now for that also one activity is given. Thus during transition of solid phase to liquid, the object absorbs heat energy, but its temperature does not increases. Remember this. Now during transition of solid phase to liquid phase, means from conversion from solid to liquid, what happens? The object absorbs heat energy. Now for example, we can take the same activity which we have already seen, but its temperature does not increases. Now this heat energy is utilized for weakening the bonds between the atoms or molecules in the solid and transform it into liquid phase. Now actually what happens? Now whatever the ice cubes are there, it is in solid form. Now when we heat that, whatever that solid it is there, so what the bonds, whatever the bonds are there, it becomes weak between the atoms and molecules, and the solid starts converting into liquid phase. Therefore, the heat energy absorbed at constant temperature during transformation of solid into liquid is called the latent heat of fusion. Underline the definition. What is the meaning of latent heat of fusion? Right? Already we have seen this is the second definition. Right? First definition we have seen about melting point of ice. Now second definition is about latent heat of fusion. The heat energy absorbed at a constant temperature during transformation of solid into liquid phase is called latent heat of fusion. So the same thing we have seen in the form of slide. Yeah. So this is about latent heat of fusion. Now, one more definition. The amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called specific latent heat of fusion. These students, you should not confuse between these two definitions. The first definition is for latent heat of fusion, and the second, which is written in dark bold color, it is for the specific latent heat of fusion. Just you see the difference. Now the amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called specific latent heat of fusion. Clear? So hope so all of you understood the first activity and these three definitions. What is melting point, latent heat of fusion, and specific latent heat of fusion. Now we'll move on the next point. Now see what is the next point. Once all the ice is transformed into water, now the same activity is going on. Now once all the ice is transformed into water, the temperature of water starts rising. Now what happens after further? When all ice which is there in the beaker, after heating, when transformed into water, the temperature of the water starts rising. It increases up to 100 degrees Celsius. Already we have seen that this temperature, what happens, it increases up to 100 degrees Celsius. Now see line BC, just look at the graph. The graph is shown. Line BC in the graph represents rise in temperature of water from 0 degrees Celsius to 100 degrees Celsius. So the line BC, what it represents the increase in temperature of water from 0 degrees Celsius to 100 degrees Celsius. Now initially we have seen what is the meaning of line AB. Line AB, what it represents the conversion of ice into water at constant temperature. Understand the difference between line AB and line BC. The line AB represents conversion of ice into water at constant temperature, and line BC represents rise in temperature of water from 0 degrees Celsius to 100 degrees Celsius, because initially before heating the temperature was 0 degrees Celsius, and as we have, after heating, what happens, the temperature rises and it reaches up to 100 degrees Celsius. Yeah, so this is the difference between a line AB and BC. Just look at the graph. Now thereafter, even though heat energy is supplied to water, its temperature does not rise. Right now, after once the temperature is reached up to 100 degrees Celsius, and still you are heating the mixture, even though after heating also the temperature is not going to rise. It will remain constant, that is up to 100 degrees Celsius. Already we have seen in the last slide. The heat energy is absorbed by water at this temperature and used to break the bonds between molecules of the liquid and convert the liquid into gaseous. Now here see what happened. Now initially what happened, the solid is converted into liquid phase. Now this liquid phase will convert into gaseous form, or we can say in the form of steam. So the heat energy is absorbed by water at this temperature during used to break the bonds between molecules of the liquid and convert the liquid into gaseous state. Thus, during transformation from liquid phase to gaseous phase, heat energy is absorbed by the liquid, but its temperature does not change. Now here also, from during transition or during transformation from liquid phase to gaseous phase, the heat energy will be absorbed by the liquid, but its temperature does not change. It will remain same, that is 100 degrees Celsius. Even if you heat continuously heating for half an hour, the temperature will remain same, that is 100 degrees Celsius. But what is going to happen, that liquid will convert into gaseous state, or we can say the liquid will convert into steam. Now the constant temperature at which the liquid transform into gaseous state is called the boiling point of a liquid, right? Now you can see the definition. Already we have seen the definition for melting point, as I told you to underline that. Now the fourth definition is for the boiling point of the liquid. The constant temperature at which the liquid transforms into gaseous state is called the boiling point of the liquid. Please underline the definition and understand the difference between the melting point and boiling point. What is melting point? The constant temperature at which the ice converts into water is called the melting point of ice. And what is boiling point? The constant temperature at which the liquid transforms into gaseous state is called the boiling point of the liquid. So these are the two definitions. One is for the melting point and one is for the boiling point. Now from this activity, whatever this paragraph, now what we can see, the heat energy absorbed at constant temperature during transformation of liquid into gases is called the latent heat of vaporization. This is the fifth definition. Clear earlier? Now just if you want to study this, just make the difference between latent heat of fusion and latent heat of vaporization. The whole concept will be cleared for you. Just I will tell you. Now if you see in latent heat of fusion, what we have seen, the solid is converted into liquid, correct? And in latent heat of vaporization, what the liquid is converted into gases. So you should understand this difference. Means it will be easy for you to learn the definition. Now see, once again, just I will repeat the definition for latent heat of vaporization. The heat energy absorbed at during transformation of liquid into gas is called the latent heat of vaporization. Clear? Now same specific latent heat of vaporization, which is written in the bold color if you see in the textbook. So what is the definition for that? The amount of heat energy absorbed at constant temperature by unit mass of a liquid to convert it into gaseous phase is called the specific latent heat of vaporization. So all the definitions are clear for you. Clear? The first one is melting point of ice or melting point. Second one is latent heat of fusion. Third one is specific latent heat of fusion. Then boiling point. Then latent heat of vaporization. And the last, now what we have seen, specific latent heat of vaporization. Both study properly. There should not be confusion between the definitions. Clear? Solid into liquid, latent heat of fusion into gaseous, latent heat of vaporization. If you understand this point, whole definitions you can learn it. Clear? Now if you see on page number 63, one table is given. So we'll go through that. Now see, different substances have different melting points and boiling points. So as you know that whatever the different substances will have different melting points and boiling points. So the values of this melting points and boiling points and latent heat depend on atmospheric pressure. Now we'll see some of the examples. Some of the substances are given. You can see on page number 63, and even you can see the slide which is given. Now see, first we'll see which are the columns. Substances, melting point in degree Celsius, boiling point in degree Celsius, then specific latent heat of fusion, kilojoule per kilogram, and in second one, calorie per gram. Then specific latent heat of vaporization, kilojoule per kilogram and calorie per gram. Now see, the first substance is water or ice. The melting point of water or ice is 0 degrees Celsius and boiling point is 100 degrees Celsius. Now we'll see what is the specific latent heat of fusion. It is 333 kilojoule per kilogram and 80 calorie per gram. Clear? Please go, you have to learn this, you have to go through this properly because anything can be asked for the exam. So please understand by heart it. Then specific latent heat of vaporization, it is 2256 kilojoule per kilogram and 540 calorie per gram. Clear? So this is about the first substances, water and or ice. Now we'll see for the second, that is copper. So melting point of copper is 1083 degrees Celsius and boiling point is 2562 degrees Celsius. Then specific latent heat of fusion, it is 134 kilojoule per kilogram, 49 calorie per gram for the copper. And specific latent heat of vaporization is 5060 kilojoule per kilogram and 1212 calorie per gram. So this is for the second substance, that is copper. Now the third substance is ethyl alcohol. Just see the melting point. Melting point of ethyl alcohol is minus 117 degrees Celsius and boiling point is 78 degrees Celsius. Then specific latent heat of fusion of ethyl alcohol is 104 kilojoule per kilogram and it is 26 calorie per gram. Then specific latent heat of vaporization of ethyl alcohol is 8540 kilojoule per kilogram and 200 calorie per gram. So it is given both in kilojoule per kilogram and calorie per gram. Then fourth substance is gold. The temperature of the melting point of gold is 1063 degrees Celsius and its boiling point is 2700 degrees Celsius. The specific latent heat of fusion of gold is 144 kilojoule per kilogram and 15.3 calorie per gram. Then specific latent heat of vaporization of gold is 1580 kilojoule per kilogram and 392 calorie per gram. Clear? In the same way, it is given for silver and lead. For silver, the melting point is 962 degrees Celsius. Boiling point is 2162 degrees Celsius. The specific latent heat of fusion, it is 88.2 kilojoule per kilogram and 25 calorie per gram. Then specific latent heat of vaporization is 2330 kilojoule per kilogram and 564 calorie per gram. And the last example or the last substance is lead. The melting point is 327.5 degrees Celsius. Then boiling point is 1749 degrees Celsius. Then specific latent heat of fusion for lead, it is 26.2 kilojoule per kilogram and 5.9 calorie per gram. And last, that is specific latent heat of vaporization of lead is 859 kilojoule per kilogram and 207 calorie per gram. So please go through this chart, learn it by heart. Clear? So this is the first point what we have completed, that is latent heat. In that we have seen what is melting point, we have seen what is boiling point, then we have seen the difference between latent heat of fusion and latent heat of vaporization. So there should not be any confusion about this activity. Correct? Now we will move on the next point, that is use your brain power, which is given on page number 63, last one. Now see what is the first question asked. Is the concept of latent heat applicable during transformation of gaseous phase to liquid phase and from liquid phase to solid phase? Means the concept what we have seen, whether it is applicable from transformation of gaseous to liquid and from liquid to solid. So the answer is yes. You can write down the answer. The answer is yes. Then second question, where does the latent heat go during this transformation? So during this transformation, what happens? The latent heat is given out by the substances to the surrounding. Clear? So here we have completed our first point. Now we will move on the next point, that is regulation. This point is also very important point from the exam point of view. So here also one activity is given. Clear? Now see what is regulation. First we'll see the definition. You may have seen the preparation of an ice ball. Clear? In the figure you can see the ice ball is shown. First an ice slab is shredded and then the shredded ice is pressurized around the tip of the stick to prepare the ice ball. Now see what are the question asked. First question is, how does the shredded ice convert into the solid ice ball? Then second one, if two small pieces of ice are taken and pressurized against each other for a while, they stick to each other. Why does this happen? Clear? Now see, to understand what is the meaning of regulation, we are going to perform one activity. So the activity is given. Take a small slab of ice. So look in the slide, small slab of ice, a thin wire and two identical weights. So same, we are going to take two weights which are of the same. Now, so see what is the activity. Put a slab of ice on a stand as shown in the figure. Right. So what we are going to do, we are going to take the table or something and we are going to put the ice slab on the stand. Then hang two equal weights to the two ends of a metal wire. So with the help of the metal wire, we are going to hang both the weights on the east side and put the wire on the slab as shown in the figure. So you can see how it is. That wire is kept on the glass. Now what do we observe? Now after doing this activity, what is the thing we are observing? Now see what happens. It is observed that the wire gradually penetrates the ice slab. Means when you do this activity, when we are doing this activity, the wire, the metal wire or the thin wire, it slowly penetrates, means it goes inside the ice slab. After some time, just look in the slide, you can see the wire, it is moved, inserted, or it is went inside the ice slab. After some time, the wire comes out of the lower surface of the ice slab. Now, after sometimes what happens, whatever the wire is there, because it has got equal weights on both the sides, so that wire will come down from the lower surface. However, the ice slab does not break. Remember this, the ice slab will not break, it will remain as it is. So that only we are going to see that how this happens. Clear? Now, so that is only called as regulation. Now see what is the definition. The phenomenon in which the ice converts into the liquid due to the applied pressure and then reconverts to ice when the pressure is removed is called regulation. Remember the definition and the activity, both things, this activity and the definition is an important point. So what is the definition for regulation? The phenomenon in which the ice converts to liquid due to the applied pressure and then reconverts to ice once the pressure is removed is called regulation. Clear? So maybe you understood this activity and even the definition of regulation. Now we'll see how it happens. The melting point of ice becomes lower than 0 degrees Celsius due to pressure. Now we have applied the pressure, by we are putting the weights on the ice slab, means what we are doing, we are giving pressure, right? So what happens, the melting point of the ice goes lower than 0 degrees Celsius due to pressure. This means that at 0 degrees Celsius, the ice gets converted into water. Means we are pressurizing, means what will happen, the ice, it will get converted into the water. As soon as the pressure is removed, now slowly as the wire, it is going down, penetrating down, so what will happen, the pressure will be removed. So as soon as the pressure is removed, the melting point is restored again to 0 degrees Celsius, and again the water gets converted into ice again. So because that is why, even though the wire, it goes down, it penetrates down from the lower surface, then also the ice slab will not break, it will remain again, that ice will, water will convert into ice, and in this, that is why the ice slab will remain as it is. Yeah, so this is very, very important point. If even sometimes you can do this activity at home and you can try it, that how it happens. So clear, all of you understood what is the definition of regulation, right? Regulation means what? The phenomenon in which the ice converts to liquid due to the applied pressure and then reconverts to ice once the pressure is removed. This is called regulation. Clear? So it is very, very important point. Now see, after, depending on this activity, some questions are asked, so we'll go through that question. Now see what is the first question. Use your brain power. In the above experiment, the wire moves through the ice slab. However, the ice slab does not break. Why? So already we have seen the answer. Just once again we'll repeat. So see what is the answer for this question. When the thin wire with 2 equal weights attached to its ends is hung over the block of ice, it exerts pressure on the ice below it. Due to this, the melting point of the ice below the wire is lowered and some ice starts melting. The wire passes through the water so formed. Already we have seen in the activity. What happens because of the pressure? The wire passes through the water. The water above the wire. Clear? Now the wire is penetrated. So the water above the wire is no longer under the pressure, because the pressure will be down on towards below. Above there will be no any pressure now. So the water above the wire is no longer under pressure and therefore again refreezes. Refreezes means again it will start converting into ice. Once again the ice below the wire melts. Because of the pressure, what will happen? The ice below the wire melts and the wire passes through it. And the process continues. So in this way, what happens? The process continues. In this way, due to the alternate melting of ice and freezing of water or refreezing of water, the wire cuts right through the block of the ice, leaving the block intact. Clear? So the same activity what we have seen above, the same answer you can write in your own words. Clear? So understand the activity, what is the meaning of regulation, and try to demonstrate or try to write the answer in own words. Once read it and try to understand and write in your own words. Clear? So this is the answer for the first question. Now we'll see the second question. Is there any relationship of latent heat with the regulation? So understand it, this question can become, is there any relationship of latent heat with the resolution? Because the first point what we have seen, that is the latent heat, and now the point we have seen, that's the resolution. Now see what is the answer for this. Yes, remember, yes, there is a relationship between latent heat and with the resolution. Now how it is? When ice melts, heat is absorbed, correct? When ice melts, heat is absorbed, but the temperature does not changes. Also, when water refreezes in the regulation, heat is given out, but the temperature does not changes. Clear? In the both activity, the temperature does not changes. When ice melts, heat is absorbed in the first activity what we have seen, but the temperature does not changes. Also, when water refreezes, that we have seen in the regulation, this activity, heat is given out, but the temperature does not changes, and this heat absorbed or given out is the latent heat. Clear? So yes, there is a relationship between latent heat and the regulation. Now, next question, third question is, you know that as we go higher than the sea level, the boiling point of water decreases. What would be the effect on the melting point of a solid? Remember, such questions can be asked for the exam. So what is the question? You know that as we go higher than the sea level, the boiling point of water decreases. What would be the effect on the melting point of the solid? So as we go higher than the sea level, the melting point of the solid, first one, that expands on melting is low pressure. So first what happens, that expands on melting is lower due to decrease in pressure, and that contract on melting is raised due to decrease in pressure. So you can write down the answer for that question. Now the one more question is asked, can you tell? We feel that some objects are cold and some are hot. Is this feeling related in some way to our body temperature? Remember this. Now when we touch something, we understand whether the object is hot or whether the object is cold. Now how is this feeling related in some way to our body temperature? Clear? Now see what is the answer for this. Yes. If the temperature of the object is lower than our body temperature, that is ice, we feel the object is cold. Please understand, if the temperature of the object is lower than our body temperature, for example ice, we feel the object is cold. Clear? And suppose if the temperature of the object is higher than our body temperature, example hot water, we feel the object is hot. Clear? So whenever we feel, when we touch any object, when we feel whether it is hot or cold, it depends upon our body temperature. If the temperature of the object is lower than our body temperature, then the object is cold, and if the temperature of the object is higher than our body temperature, then we feel that object is very hot. Clear? So this is about regulation and one of the activities. So whatever the points we have seen today, the first one is about latent heat, then regulation. Clear? So what you have to do, you have to read page number 62, page number 63, page number 64, and you have to understand whole concept once again. Clear? Because we have seen the difference between temperature and heat. Then we have seen what are the different ways of heat transfer: conduction, convection, right? And after that we have seen latent heat. In that, so many definitions we have seen: boiling point, melting point, latent heat of fusion, then specific latent heat of fusion, specific latent heat of vaporization. So many definitions are there in this lesson. And after that, you have seen different substances, their melting points, water, copper, ethyl alcohol, gold, silver difference. One chart we have seen. And the last point we have seen about regulation. In that also we have seen some of the questions, right? Use your brain power. In that some questions are. Then can you clear? So hope so all of you understood whatever the points we have seen today. Now again so many points are there, like anomalies behavior of water, which are very important. Hooke's aperture, dew point humidity. Now the next point we will see tomorrow in the next play. Clear? Now whatever things we have seen today, from that what you can do, you can evaluate yourself. You can tell some of the answers that whatever we have seen. Now see what is the first question. What is boiling point? So you have to define that. What is boiling point of liquid? So those who know the answers, you can raise your hands and you can tell the definition.
Hello, good morning, sir.
First
I am
one.
Diksha. Can I answer?
Hello, who is speaking?
I am Diksha.
Hello. Okay, you can tell the answer. First question is, what is boiling point of liquid?
Sir, the constant temperature at which the liquid transform into gaseous state is called the boiling point of the liquid.
Okay, very good. Right. So the answer, all of you know the answer. The constant temperature at which the liquid transforms into gaseous state is called the boiling point of the liquid. Very good. Then the second question is, what is melting point of ice? Those who know, they can raise your hands and they can tell the answer. What is melting point of ice?
This constant temperature at which the ice converts into water is called the melting point of ice.
Okay, very good. The constant temperature at which the ice converts into water is called the melting point of ice. And apart from that, we have seen one more definition, that is what is resolution. That also definition anyone can tell. What is resolution?
Second answer.
Who is same Diksha is speaking?
Yes, sir.
Okay, continue. You can tell.
Sir, the phenomenon in which the ice converts to liquid due to applied pressure and then reconverts to ice once the pressure is removed is called resolution.
Okay, very good. Right, the phenomenon in which the ice converts to liquid due to applied pressure and then reconverts to ice once the pressure is removed is called resolution. Now just we'll see one more definition. Any other person can try. Last one. What is latent heat of fusion? Some other person can answer. Students can answer this last question. What is latent heat of fusion?
No
Anyone?
one else is raising their hand, students.
Hello, sir. Can I answer?
Who Diksha is there?
Yes, sir.
Him. Okay. You can continue. If no one is there, then you can answer.
Sir, the amount of heat energy observed at constant temperature by unit mass of a solid to converts into liquid phase is called the latent heat of fusion.
No, see what is the question? What is latent heat of fusion? No, not a specific latent heat. I am asking about latent heat of fusion. The heat energy absorbed at constant temperature during transformation of solid into liquid is called latent heat of fusion. That is why I told you don't confuse between latent heat and specific latent heat. Understood?
Yes, sir.
Don't confuse between the 2 points. Both the definition, there is some two difference. Only 2 words difference is there in both the definitions. So understand the concept properly.
Okay.
Yeah. So once I can go through all the things, that point whatever we have seen, latent heat, then 2 activities, and the last one, that is resolution. So go through that activity. Tomorrow we'll continue the next point, that is animals behavior of water and Hooke's apparatus, which is very important from the exam point of view. Clear? So thank you, students. Thank you.
Thank you, sir.
Okay, thank you, ma'am.
Students, for today we have completed all the 4 lectures. Please revise at home and prepare yourself. Any doubts still, you can ask in the next lecture. Thank you, sir. Thank you, students.
Thank you, ma'am.
Students, I'll wind up the lecture over here. I'll end up the session.